Hello and welcome to Nikolai's genetics lessons and the problem of the day. The wheat variety with red kernels, genotype A', B', was crossed with a variety with white kernels, genotype AABB. The F1 were intercrossed to produce F2 generation. If each primed allele increases the amount of pigment in the kernel by an equal amount, what phenotypes will be expected in the F2 generation? Assuming that the A and B loci assort independently, what will be phenotypic frequencies? And here is how we are going to solve this problem. One parent genotype A', and B', we cross with another parent whose genotype is AA and B. So parent 1, parent 2. This is parental generation, and this is how we are going to get F1 generation. And in F1 generation, we are going to get only one genotype, which is A', and B', which we intercross, meaning we cross with itself, A', and B', In the next generation, which is going to be F2 generation, we can get any combination of these alleles, because this is additive trait, and each allele would add to the trait the same amount of the pigment. Let's say that those with prime would be 1. So genotype would be 1, and those without prime would be 0. So would add 0 to the phenotype. So would be 0. So 1, 0, 1, 0, 1, 0. Now in F2 generation, we can get following genotypes and phenotypes. First variant of the phenotype would be when all 4 alleles would be prime alleles. Another variant would be when we will have 3 alleles that is going to be prime and 1 would be 0. Another variant would be 2 primes and 2 0. Then 1 prime and 3 0, and all 4 0. So now let's list the frequencies of these genotypes and phenotypes. How many variants possible to have 4 prime alleles? Only 1. So it can be A', and B'. How many variants possible to have 3 prime alleles and 1 allele which doesn't add anything to the trait? So take a look. We can get A', and B'. Another variant would be A', and B and B'. Another variant would be A', and A, B', B'. And the last variant would be A', B', and B'. So we have listed all variants possible. And as for the genotype with 2 primes and 2 0 alleles, we are going to have following genotypes. So A', and B. Next variant would be A', and A, B', B. Another variant A', B, and B'. One more combination A', B', and B. One more combination A', B, and B'. And the last combination would be A, and B', B'. So 6 combinations here. And as for the rest, phenotypes and genotypes, it's going to be just mirror reflection of what we have here. So 1 prime allele and 3 0 allele. So it's going to be A prime, A, and B, B, A prime, and B, B, A, B prime, B, and A, B, and B prime. And the last combination where we will have all 4 alleles, which doesn't add anything. We just have one combination, which is A, and B. How many phenotypes we have? 1, 2, 3, 4, and 5. 5 phenotypes. Now let's find frequency. And the frequency is going to be how many genotypes we have total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the frequency of this phenotype is going to be 1/16. So 1/16 is going to be dark red. So dark red. And as for the frequency of this phenotype, we have 3 prime alleles and 1 which adds 0. So it's going to be red, and the frequency is 1, 2, 3, 4. 4/16. So 4 out of 16 is going to be red. And here we have 2 alleles prime and 2 which add 0. So 6 out of 16 would be intermediate color and would be pink. So pink. And 4 out of 16 is going to be light pink. And 1 out of 16 is going to be white color. So this kernels is going to be white. So again, we got 1, 2, 3, 4, 5 phenotypes, and here are the frequencies. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day, and see you in the next video. Goodbye.